Well done. Welcome to our channel once again. So today, we want to quickly run through the volumetric analysis for Neco 2025. So let's see what we have this year, 2025. Our acid given is HNO3, which is triazonitrate 5 acid, and our base is a mixture of sodium carbonate and sodium nitrate. So don't be confused. If you are seeing question telling you that your base is a mixture of this compound and this compound, simply know that the reaction between HNO3 and sodium carbonate is a neutralization reaction. So adding sodium nitrate to this mixture does not change anything. Sodium nitrate does not react with HNO3. So it is inert, it will not be reactive. So the only reaction that will take place is between HNO3 and sodium nitrate. And we are going to have our equation. And the equation of our reaction will not contain sodium nitrate because it's simply an impurity. It's forming impurity in this mixture. Now, let's quickly run through a particular question that can be expected during our Neco practical chemistry on Monday. Now, we have our question here. A is a solution of 0.10 mole per dm cube of triazonitrate 5 acid, which is HNO3. B is a solution, is a mixture of 8 grams of sodium triazocarbonate 4, which is sodium carbonate, and sodium triazonitrate 5, which is sodium nitrate, forming impurity, in 1 gm cube of solution. Now, from here, the instruction says put A into the burette and titrate against 20 cm cube or 25 cm cube of B, using methyl orange as the indicator. This is our indicator. Now, repeat the titration to obtain consistent values. Tabulate your readings and calculate the average volume of A used. From your result and information provided, calculate number 1, concentration of B in mole per dm cube, mass of sodium carbonate, which is pure base, in 250 cm cube of B, mass of sodium nitrate in the mixture. Then number 4, percentage purity of sodium carbonate and percentage impurity of sodium nitrate. We will calculate the percentage purity of this because it's a pure base. I'm expecting to calculate the percentage impurity of this because it's an impure compound added to our mixture. Now, number of hydrogen ion in mole per dm cube. So, and likely questions. Now, let's quickly run through our solution. The equation of our reaction is HNO3 plus sodium carbonate. So, sodium nitrate will not be involved because it's just forming an impurity and it's not reactive. Now, we have 2 mole of sodium nitrate plus water plus carbon 4 oxide. So, the ratio, the number of mole, the mole ratio of acid to base is 2:1. That means our Na is 2, while our Nb is 1. Now, creating our table. So make sure you follow the instruction from your teacher and get your correct theta value. This theta value is not for everybody. It's peculiar to myself that I did my practical. Now, we have burette reading in centimeter cube, final burette reading in centimeter cube, initial burette reading in centimeter cube, then volume of A, because we use A in centimeter cube. Now, this is the first title, my second title, and third title. It's not compulsory that you start with rough because your best capacity might be demonstrated in your first titration. So you will get the best result. Now, I'm starting my initial titration with 0.00 and this is the result, 24.8. So I got the second one started with 1.00 and result was 25.70. So the third one from 2.00 and the result gave 26.70. So this is the final volume we got in. So for the first titration, we got 24.8, second 24.7, third 24.7. So you can see it's obvious that we have consistency in our readings. So we have concordant readings here. So now we calculate the average volume of A, which is A, the acid in our burette used. As we can see, our titration shows that after doing our titration, we have our color change from yellow to orange, as you can see here. So then you read your theta value very well and take the last calibration where the volume of the acid is sitting. Now, Here, you want to calculate the average volume of AUs. You take, I'm taking second title plus third title. I can take first and second too. I can take any one from the three, but I decided to take second and third. So I managed 24.7 plus 24.7 divided by 2. So I got this. So then my final result is 24.7 cm. That's my V. So and the question told us that from my readings, I should calculate the concentration of solution P in mole per dm. So how do I do that? So from this formula that says CAVA over CBVB equals to NA over NB, this formula. So I'm looking for concentration of solution B, which is CB here. Then I will itemize everything here. Let me bring every values given. Out here, we have CA to be 0.1, 0 mole per dm cube. CB, we don't know it. That's why it's question mark. Volume of acid use, VA, that's our average title value, which is 24.7. So our volume of base, like VB, so is the volume of the pipette that was used to pipette our base during titration, and it's 25 cm3. Then MA is the number of mole of acid in our equation, which is 2, and MB, which is 1, number of mole of base. Now, from here, we have our CB to be CAVA NB over VB NA. So substitute these values into this formula, and we got 2.47 over 50 here. So when you divide it, you get 0.0494 mole per dm cube. This is our CP. Now, the second question says that we should calculate mass of sodium carbonate in 250 cm cube. So now, from this formula, we have concentration in gram per dm cube equals to concentration in mole per dm cube times molar mass. Now, we know purely that if you are doing concentration in gram per dm cube, it's talking about mass concentration. Concentration is in mole per dm. Now, from here, we are just calculating mass concentration, like mass of sodium carbonate in 250 cm cube, right? Now, we know that molar mass of sodium carbonate is 106, and our mass concentration in gram per dm cube is mole per dm cube, which is 0.0494 mole per dm cube, times molar mass, which is 106 here. And the final answer is 5.2364 gram per dm cube. So this is our concentration in gram per dm cube. That's our mass concentration of sodium carbonate. Now, take note. So this sodium carbonate is our pure base. It means this mass concentration is the mass concentration of pure base. Mass concentration of our pure base here. Now, the question says that we should calculate the mass concentration of this in 250 cm cube. So anytime you have this in gram per dm cube, dm cube means in 1000 cm cube. So it means we have 5.2364 gram to 1000 cm cube. But the question says we should find it in 250 cm cube. What do? We just take S gram to 250 cm cube and we cross multiply. So this one will give us 5.2364 times 250, which is what we have here, divided by 1000. This is what we have here. So if you carry out this, you have 1309.1 divided by 1000, and the final answer is 1.3091 gram. That is 1.3091 gram in 250 cm cube of the solution. So that is the answer. Now the next question says we should calculate the mass of sodium nitrate in the mixture. Now let's quickly go back to our question. So the question says solution B is a mixture of 8 gram of sodium carbonate and sodium nitrate. Now we now have the mass of sodium carbonate here in gram per dm cube, which is this mass of sodium carbonate is 5.2364 gram per dm cube, and the total gram is 8. So and we have just two compounds in that mixture, sodium carbonate and sodium nitrate, and sodium carbonate is already having this 5.2364. And now say we should calculate the mass of sodium nitrate in the mixture. So what do? Just take the total mass, which is 8 gram minus 5.2364 gram, and it will give you 2.7636 gram. That is the mass for sodium nitrate that forms impurity in our compound. Now, the next question says we should calculate the percentage purity of this compound, sodium carbonate, because these are our pure base, right? what do we do? This is the formula. Percentage purity equals to mass concentration of pure base, which is sodium carbonate, over mass concentration of impure, that is mixture, multiplied by 100. So what is the mass concentration of our pure base? Let's come here. Mass concentration of our pure base, this is it. Take 5.2364, then you put it here, over 8, which is for the mixture, times 100. And the answer is 5.455%. That is the percentage of sodium carbonate in that mixture. Now, they said we should calculate the percentage impurity of this sodium nitrate. Since the formula for percentage purity is mass concentration of pure base over mass concentration of the impure, which is the mixture. So the percentage impurity will be mass concentration of impure base over mass concentration of the mixture times 100. So that means you go and look for the mass concentration of the sodium nitrate, which is 2.7636 over 8 multiplied by 100, and you have 34.545. So if you had 65.455 plus 34.545, you get 100%. So that is the final answer. It must give you 100. So in other way, you can say, since you know the percentage purity of this, and they ask you to calculate percentage impurity, you can simply say percentage impurity equals to 100 minus percentage purity, and it still give you the same answer. Now, the last question says we should calculate number of hydrogen ion in 1 dm cube of HNO3. What do you do? So you take your HNO3 out and you dissociate it. You have hydrogen ion plus NO3 minus. So it means 1 mole of hydrogen ion produces 1 mole of, and 1 mole of HNO3 produces 1 mole of hydrogen ion. So there is no multiplication with any number of moles. It's just 1:1. So you now take your Ca, which is concentration of A, Ca, which is given to be 0.10 mole per dm cube from our question. And what do? You multiply it by Avogadro's number. And our Avogadro's number is 6.02 times 10 raised to the power 23. 6.02. So if you multiply 0.1 times 1, which is number of mole of hydrogen ion, times 6.02 times 10 raised to the power 23. So the final answer will be 6.02 times 10 raised to the power 22 ions. That is the unit. And that is the final answer to the last question. Please share with everybody, subscribe to our channel, remember to follow, and drop your comment. Thank you, everyone.